Hi guys, in this first video I'm going to be covering displacement mapping, and this shield is what we're going to be working on. So displacement mapping in a nutshell is a process whereby the vertices in a 3D mesh are moved or displaced dependent on information stored in a 2D image. Now I'm going to go into more detail about how exactly that works in a minute. But the first thing I want to discuss is the fact that displacement mapping, in order to be useful and effective, requires a separate process. This process is called tessellation, and in the case of Marmoset Toolbag 2 is the first widget in the top right hand corner of the material palette. So why is displacement mapping reliant on tessellation? Well, let's think about the displacement mapping process. Essentially what you're doing is moving vertices on a mesh to form more detail for that mesh, or in some cases to form an almost completely different mesh. So logically it must follow that your final product has the same number of vertices as your original mesh. Now, unless you're doing some kind of animation or a transformation using the displacement, then this isn't very useful. Because if you just want to see your final product, if you don't want to at any point see the original mesh, the whole displacement process that the computer has to go through to render your new product is completely pointless. Because if they have the same number of vertices, why didn't you just have the new or the final product from the start? So this is where the tessellation comes in. And what tessellation does is subdivide every poly on your mesh, creating more vertices which can then later be displaced. So let's use the shield to give you an example. If we pop to the renderer and turn on the wireframe, you'll see that the shield has a lot of vertices in the mesh. But if we turn the tessellation down to 0, you'll see the original number of vertices, and that in this case there aren't very many of them. Also, because of the lack of vertices, our displacement is suffering greatly. We haven't got any of the little bolts sticking out. We've got one point on the main bulge of the shield. There's just no real detail to speak of. But as we turn up the tessellation, you'll see more and more vertices being formed, and all the detail will slowly pop in. So now we know why displacement mapping is reliant on tessellation, but we haven't talked about why all of this is necessary. Why you would go through the process of tessellating a low poly mesh and then displacing it to form your new mesh. Why won't you just have the final product? Now I'm going to answer this from the point of view of games creation. I'm not going to talk about movies or anything of that kind of nature. So in games there are two main benefits for using this process, or these processes. The first is in loading times. If you picture a level or a map within a game and you take all of the models out and replace them with lower poly versions of themselves, which will then get tessellated and displaced, and hopefully by the end look exactly as the original ones had, you will have taken out thousands, possibly millions of vertices from the loading stage of that level. So effectively you have shortened the loading time for it. You will, however, have to load in the 2D images that will then go on to displace your meshes. However, the time saved by taking out all of the vertices more than makes up for this additional loading time. The second benefit of these processes is that tessellation, or the level of tessellation, can be controlled dynamically. This means that objects which are far away from the player or hidden from the player's view can have a low level of tessellation or even no tessellation. What this does is saves on the real-time rendering, because you only really need the detail on things which are close or on screen. So by controlling the level of tessellation throughout the level based on where the character is and where they're looking, the efficiency of the whole level is increased. Now I should point out that whilst both of these benefits are true, tessellation as a process is very heavy on real-time engines such as games, and they haven't quite been developed to the level where they can just be used on anything and for everything. Okay, so we've talked a lot about how displacement mapping and tessellation are linked, and we've also talked about the benefits of using them. Now I want to go back and continue talking about how displacement mapping works. So we've already established that displacement mapping is the movement of vertices. What we haven't said so far is that vertices can only be moved in the direction of their vertex normal. So that we don't get bogged down in too many little details, I'm going to go ahead and assume that you already understand what vertex normals are. It's important to remember that whilst the displacement of the vertices can only occur in the direction of the vertex normals, that this displacement can be either positive or negative. Now, I'm hoping this next bit is going to make what I've just said a bit more clearer. So what I'm going to do is go ahead and bring up the 2D image that represents our displacement. Incidentally, these images are called Heightmaps, or sometimes when they're used for the purpose of displacement mapping are referred to as displacement maps. So how does this work then? Well, the color intensities of our height map represent the intensity of the displacement of our vertices. This middle gray here is used to represent no displacement. Any areas which are lighter than that, such as this middle part here, or any of these knobs around the edge, are representing positive displacement. Conversely, any parts which are darker than the middle gray, such as these slats, or even darker still, these little slits, represent negative displacement. Right, it's about time I explained what I meant when I was talking about negative and positive displacement. So what I'm going to do is just put that across there, hide that a little bit, and pull this window down here. Let's quickly rotate the shield and drop the displacement to 0. Okay, so what I'm going to do in a second is slowly increase the scale of displacement. While I'm doing this, I want you to pay attention to the direction of the displacement of the vertices. Okay, so let's slowly slide this up till about there. Right, so what we should have seen is that in these darker areas of our height map, the areas which I said were indicative of negative displacement, the vertices were displaced inwards into the shield. Whereas in the lighter areas, the vertices were displaced outwards or away from the shield. I'm just going to slide the scale down and back up again quickly just to show you. There we go. Now, before we move on to generating height maps for yourselves, I want to revisit vertex normals, because whilst I've been demonstrating the displacement in this front area of the shield, all the vertex normals there are in the exact same direction. And I would like to show you the results of the displacement in an area that has less uniform vertex normals. So let's go back to full screen, take the displacement scale back down to 0, bring up the wireframe and zoom into this area here. So this time, as I increase the displacement scale, I want you to watch the vertices along these edges. As you saw, these vertices were not displaced at all. Instead, the vertices on these top faces were used to form the curve of our shield. Now, this is all to do with the direction of the vertex normals. So if I take the displacement scale down again, these vertices on this edge here, get a better angle on it. There we go, that's probably as good as we're going to get. But these vertices will have a vertex normal which is in roughly this direction here. Therefore, when the displacement occurs, they are not used to form the curve because of the vertex normal being in the wrong direction. So the vertices on top are used instead because their vertex normals are closer to the direction that is required to form the curve. Right, with that covered, we can now move on to the process involved in generating the height maps. I'll just go ahead and open the Shield version 1.0 3ds Max file, and I encourage you to do the same. Now, since this isn't a modeling tutorial, I'm not going to go into any kind of detail about how these models were constructed. But the one thing that I do want to point out is that at this stage, the low poly model should be unwrapped and should not have any areas which are overlapped. So as you can see, there's no overlapping faces on this model. Now, if you're clever, you can sometimes get away with overlapping areas, but quite often they turn out to be more trouble than they're worth. So let's collapse the modifier stack and we can start to export the objects. Now I'm going to start with the high poly model, and the first thing I want to do is just check that it's centered to the world by looking at the global coordinates just down here, and it is. So I'll select all of the objects, go to File or the 3ds Max icon up here in the left corner, go to Export, making sure we go to the little arrow and Export Selected. Now I'm just going to put mine on the desktop, but obviously you can put it wherever you like, making sure that it is in OBJ file. I'm going to save it as shield underscore HP for high poly. Now I'm going to hit save. Okay, you should get this little window popping up. Now the only settings you need are these four here. The 3ds Max will like to have this, so just leave that in there. You can actually check if these are the right settings by going to the presets and jumping to the Mudbox one, and you can see the settings are almost exactly the same, except I like to have the normals there as well, just because when you import the objects, it doesn't have to work out the normals for all the vertices on its own. So I'm just hit export, and while this is exporting, I'm just going to explain why I'm not bothering to send these objects directly to Mudbox using the send to feature here, and that's because I'm going to be displaying both of these objects in Marmoset Toolbag 2, so I'm going to need to export them at some point anyway, so might as well do that now. Alright, let's go ahead and export the low poly. But first thing we need to do is to make sure that it is overlapping our high poly. Then we can go ahead and do the same thing. Go to File, Export, Export selected, this time saving it as shield underscore LP, this time for low poly. Hitting save. Now it'll keep the same export options, so just hit export again. And that one was a lot quicker. Now I'll go ahead and open up Mudbox with a fresh scene. Then we want to go to File, Import, and select, let's do our high poly first. Now you'll get this pop up with these problems that Mudbox has detected. The UV ones we can just ignore because we're not going to be using the UVW coordinates of our high poly. Now the high valence vertex 1 might be an issue, but let's just hit keep all for now and see if it is. So this red dot here shows you the area of the high valence vertex, but if we zoom in, we'll see that there isn't any visible issues with that, so we can safely ignore it. Now I'm going to quickly just hide all of these and import the low poly. Now we get the high valence vertex issue again, but we can again just ignore it for now. This time we've got it in two places, one on the back and one on the front. So now we have both of our objects in Mudbox. What is the next step? Well, we'll first need to set up what's known as our extraction operation. And the way we do that is we go to UVs and maps, extract texture maps, and new operation. We get this pop-up window where the first thing we want to do is select the maps that we want to generate. So in our case, we want ambient occlusion, displacement, and normal maps. Let's just push that up a little bit so you can see the whole window. Now we should be presented with all of these options, but what I'm going to do is quickly pop back up to the ambient occlusion ones. The first thing that it asks us is to input our low poly mesh. So what I'm going to do is hit add all and then take out our high poly meshes. Now the next thing that it has is this smooth target models. Now this might be ticked for you. If it is, go ahead and untick it, because what that does is smooth out your low poly model by adding extra vertices, which is something that we do not want because later we're going to be displacing them. Now it is worth pointing out at this point that some engines do have the functionality to allow for smooth targeting on your low poly model. However, this is not the case for most engines, so it's worth getting into the habit of generating your maps without it. We can go ahead and leave the use creases option ticked. The next thing that it asks us to do is add our high poly models. So I'm going to hit add all again, and then this time remove the low poly. Now it's also got an option for smooth source models, which again we're going to want to ignore. The next set of options are these output options, and the first drop down is the quality drop down, refers to the general quality of our maps. Now I'm going to just leave mine on good for speed purposes, but feel free to change that to whatever you'd like. The next two we are not going to play with at all. Those will be automatically set to the settings that we'll want. The next one, the search distance, is the distance is how far Mudbox is going to check from our low poly for the detail to bake down. And the nice thing about Mudbox is it gives us this best guess button, which if I change this number and then hit best guess, it will take us to what Mudbox estimates is the furthest out that we'll need. It's quite useful. The next little thing is this test both sides tick box. Now this is mostly for if you have a plane which is just a plane. It doesn't have two sides, so in our case we don't need that, so I'm going to leave that unticked. The next set is the image properties options, and this first part will not apply to us because we only have one target model here. We don't have any extra ones, so we have no need for generate a map for each target, so we can just have generate one map for all targets. Then obviously we've got our image size, and we'll leave that how it is, and anti-aliasing options again. I'm going to leave that as it is. Now before we talk about these last two sections, I just want to go and point out that the settings that we have inputted for our top three sections, those are used for all three of our selected maps up here. So if I go to displacement map and then to normal map, you'll see that these settings here are all the same as our ambient occlusion, with the exclusion of this quality drop down. And that if we change, say if we change the image size to 2048, it will change it for all the others. That's just a nice little feature that Mudbox offers. I'm going to quickly pop my image size back to 1024, and we can move on to talking about the last two sections. The first of which is our advanced section. Now this is to do with the shadows for our ambient occlusion map. I'm not going to go through what all these settings are, but Mudbox standard settings are usually fine anyway, so I'm not going to go into detail about them. The last section we have is our output options. Now the first drop down is our map type, and we're given two options, ptext and texture. Now we're going to be dealing with a texture option for this tutorial. The next one is the file name and saving path. I'm going to put it again on the desktop and call it shield underscore AO for ambient occlusion. I'm going to leave it on PNG and hit save. Now we have the option to change our bits per channel. I'm going to leave it on 8-bit because we don't need a great deal of color depth for our ambient occlusion. And the next tick box is, if you have it ticked, what it will do is after it's generated them, it will put them on our target model, so you can view them straight away. I'm going to leave that ticked because it is very useful. With that done, we can move on to our displacement map options. Now we've already filled in these ones, so we can jump straight down to the displacement map options. Now what this tick box is asking is whether we wish to use the search distance that we inputted before. Now if we don't have this ticked, it will automatically detect the furthest vert on our high poly, the furthest vert from our low poly, should I say, and use that as the maximum distance. Now that's pretty much what we've done with the search distance previously by hitting best guess, so it's fine if we just have that ticked, but for whatever reason you might want to have a different search distance for your ambient occlusion and your normal maps, in which case you'd want to untick that, but for our case we want to just leave that ticked. Right, we can move down to the output options now. Leave the map type on texture again. We shall name it shield underscore dis for displacement. Leaving it on PNG again, and we'll hit save. The bits per channel I'm going to leave on 8-bit, but I would recommend turning this up if you have any areas on your high poly model which are particularly far away from your low poly. It'll just give you more colors and therefore will give you a smoother displacement. We're going to leave the preview as bump ticked as well. Now let's go back up to our normal map. Again, we've filled these in, so let's jump straight down to our normal map output. Now, these settings we want to leave as they are because the engine that we're going to be using to view our displaced low poly is going to be Marmoset Toolbag 2, and these happen to be the settings that it uses. If you're using other viewing software, you'll want to check first to see how it likes its normal maps. Right, we can go down to the output options now, leaving the map type on texture again. Let's save it as shield underscore norm. Now I'll type it all out, normal. PNG again, and hit save. I'm going to leave the bits per channel on 8-bit, and the preview as normal map I'm going to leave ticked as well. So now we've input all of our settings, we can hit extract, and hopefully this shouldn't take too long. There we go. You can just hit OK and close that window. Now, Mobbox is just calculating the targets for the tangent, for the normal map. So hopefully it'll pop in a second. Just gonna rotate around a little bit. Try and get Mobbox to remember what it's trying to do. There we go. Now the first thing we'll notice is that it's entirely black. Now that is a problem with the ambient occlusion map. We'll address that in a minute, but I'm just going to go up to the layer panel and then to the paint sections, where, here we go, select the low poly first, where it will have all of our maps that we just exported. Now I'm going to go ahead and hide the diffuse channel, which is where our ambient occlusion map was stored, so we can see everything a little bit better. Now, by and large, it looks like it's come out pretty well. However, there are a few little problems that I can see. I will go through those in a second, but what I'm going to do first is take our low poly into Marmoset 2, and I'll take you through that whole process now so we can see how well the height map has come out at the same time, because Mudbox, as you can see here, doesn't have the functionality to do the displacement mapping. So I'm going to go ahead and open up our Marmoset Toolbag 2 window. I'm going to go up to the File, drop down and select new scene. Then we want to go to the add drop down, select mesh, go to where we've saved our low poly and open that up. Now I'm just going to go to the render tab and then hide our sky background, or untick the tick box, just so we don't get distracted by that. The next thing we want to do is create our material, and the way we do that is go up here and hit new, select the new one, and to apply it to our low poly, all we need to do is drag it straight on. Now we're not going to see any changes yet because we haven't input any of our maps, so let's go ahead and do that. The first one we want to do is the normal map, and to do that we can hit this little square here, which will bring up an open window. Select our normal, hit OK, and that will apply it straight onto our mesh. Now we've already established that our ambient occlusion map is broken, so I'm not going to plug that in here. Instead we'll move on to our displacement map, and the way we do that is to go to our displacement drop down, select these little arrows on the edge and pick height. Then we can click on this little square again and select our displacement map. Now one of the nice little features that Mudbox offers us is that it puts this set of values, or not specifically this set, but a set of values on the end of our name. And what this is Mudbox telling us what it thinks our displacement scale should be. So if we hit open, we'll see that our vertices are now displaced. However, they're displaced far too much. So we're going to want to go in and set our scale. So the first thing we notice is that marmoset only goes up to a maximum value of 1. So we can't just go in and plug in 48. Instead, what we have to do is divide that value by 100. Now the next thing we want to do is divide the new value we have by 2. So we get 0.24. And this should be our scale. Now the reason we divide it by 2 after dividing by 100 is that Mudbox automatically assumes that the engine you're working in will use your black values, or your minimum negative displacement values, as your base. However, Marmoset 2 doesn't work like that. It uses the grey, as I explained before. So that's why we divide by 2 to get our right scale. So with that now done, we can see our second problem. Now I'm going to zoom in here and turn our displacement scale up a bit so you can see it. And it's the fact that these faces are pulling away from each other on the edge. Now a lot of people think that this is an issue with displacement mapping in general, but that's not true. There's actually a very easy way to fix that. Now I'm going to pop to 3ds Max and pull out this low poly. First I'm going to show you why exactly it's doing that, and it's to do with smoothing groups. As you'll see if I turn off the edges by pressing F4, that these faces, these polygons here, all have the same smoothing group. It's all set to 1, whereas these ones here don't have a smoothing group. So that's why you get this sharp edge and these faces are smooth. If we pop a edit mesh modifier and go to our vertices, make sure you have the show normals tick box ticked, we can see the vertex normal directions for all our vertices. Now these vertices on the edge here have 2 different directions. This is because of the smoothing groups. So it uses this one here for these edges, or these faces around the edge, and this one for these faces here. So we get that pulling apart. Now the way we fix this is if we go to Element, select All, go down to our smoothing group properties here, and make them all 1. If I hide all the edges, we can see that it's smoothed out our mesh, so we don't have that hard edge anymore. And also, if we go back to vertices, the vertex normal direction has now changed to incorporate all the faces surrounding it. So now, if we convert this object back to an editable poly, put it back to 0 by right-clicking these little arrows down here, and export our low poly by going to File, Export, Export Selected, and then replace our low poly shield. We can just hit OK to replace, and then hit Export again because it will have kept our settings, then hit Done. We can go back to Marmoset Toolbag 2. I'll zoom out a bit first, but we can see here that nothing appears to have changed since we've done that. But that's because Marmoset Toolbag 2 does not update meshes, even if you re-export them from your software package. So we have to go up to Add and then Mesh again to bring in our new low poly. Now I'm going to keep the old one there for a comparison. I'm going to move that over there, apply our material to it, and I'm just going to drop the scale back down to 24. But we can see with our new one, actually it's not a very good comparison, I'm going to push the scale back up again, but we can see with our new one that our faces do not pull away from each other anymore. So that is a very quick and very easy fix for that solution, or problem rather. Now I'm going to go ahead and delete our older model because we don't need that anymore because we've got the improved version. The next thing we're going to do is apply our subdivision. First let's change our scale back to 0.24. So the way that we want to apply our subdivision is by hitting these little arrows and choosing the flat option. Now the other option we're given, the PNG triangles option, that is used if you had previously in Mudbox. Let me just bring it up and bring out our extraction operation. If you had previously selected the smooth target models, then you would use the PNG triangles, but we haven't, so we're going to use the flat option. And as we can see, just applying the tessellation has improved our shield massively. I'm just going to up tessellation a little bit so you get a little bit more detail there. Now, to show you the next problem we have, I'm going to bring in our high poly mesh. So we go to Add Mesh and then bring in our high poly. So now we have that as a comparison, and we can see straight away that we've got some problems here on our edge where the inner wooden slats come in. We've got this pulling here, and we've also got, if I rotate the lights by holding Shift and just click and dragging around, you can see that the slits between each of the slats are a little bit lopsided, and that these on this side here, this side, the slope on this side here is a lot smoother or less steep than this side here, and the reverse is true on the other side, and it gets worse the further away from the center we get. Now, the reason that happens is a little bit more complicated to explain, but I'm going to give it a go anyway. So if we pop again to 3ds Max and drag, actually I'm going to leave that where it is, but essentially we can mimic what Modbox does when it's baking. It will create a cage which is basically your low poly, which is blown up a little bit. When I mean blown up, I mean pushing the faces outwards, to then use that and the original low poly to generate the height, normals and ambient occlusion maps. So the way we can mimic that in 3ds Max is going to the modifier list and selecting the shell modifier. As you can see, it's popped out just a little bit, but we want to turn that up more until it encompasses all of our high poly. And that is what our cage would look like if we could see it in Modbox. Now I'm going to make this see-through by right-clicking, going to Object Properties, and then ticking the see-through checkbox, and we hit OK, and you can see it's become a little bit see-through there. The alternative to that is pressing Alt-X, so just a little bit quicker there. So why do we end up getting those artifacts on the edge of our shield? Well, that's because Modbox will essentially draw lines between the verts of the low poly and of the expanded cage. Oops. And because of that, and because of the angle that it'll have to work at, those edges where it goes into the slats, so if I just rotate so we can see along this edge here, you'll notice that you can't see where it's going in. Unlike if you're looking straight on, you can see it's got a little bit, it comes a little bit in as it goes back. But if we rotate to here, we can't see that. And that is what Modbox will be, that will be the way that Modbox will look at it, essentially, to put it in a very simple way. So that's why we end up with those stretching artifacts. And the way we can fix that is if I get rid of this shell and bring it back so we can see it. The way we'll fix that is by selecting all of these inner edges and then adding a ring on the inside here. So if we go to connect, if we hit this little drop down here and go to connect settings, if you don't have this bar up here, you can bring it up by hitting this button, or you can go to the connect options on the side here, and it's just here. You can hit this box to bring up these options here. So what we want to do is push this edge out to the side, so it's just sitting on where it starts to go in. So if I make it see through again, you'll see it's just on the edge. Push it up a little bit more actually. just on the edge of where it starts going in. Now the reason we do this is because if I pop the shell modifier back on, shell, we can see this time that that edge there that we've just popped in has come straight out instead of going out how the edge did previously. So that's going to be going straight down. So now we'll have that detail there. Now, unlike when we edited our smoothing groups, we can't just export this and expect everything to be hunky-dory. We've got to rebake all the maps. So I'm going to collapse or delete the shell. Make sure that's not see-through anymore. Export, not import, export. So again, let's replace our low poly. There we go. Now we'll pop back into Mudbox, close that. I'm going to go and delete these. So we start with a clean slate, and we're going to have to delete this low poly because, similar with Marmoset Toolbag 2, it does, Mudbox does not refresh its meshes. So I'm going to import the new one. Get this error again. We'll just say keep all for now. Now, something I didn't mention before. The reason why we ended up getting a completely black ambient occlusion map was because Mudbox requires your high poly models to be visible when you're baking. That's because it uses the scene light, and if they're hidden, the light's not hitting your high poly, and therefore you get a completely black ambient occlusion. So let's move on to the baking stage. So we'll open our extraction operation again. Now we shouldn't need to change any settings because it should keep all the previous ones. The only thing we need to do is add our low poly into the target models. I'm going to hit add all, select the high polys and remove, and hit extract. Give it a few seconds to generate them. There we go. Okay, close that. Can now hide the high poly again so we can see everything. There we go. As you can see, our ambient occlusion map has been generated properly this time, and it looks like it's a much better bake. We haven't got any of those issues, at least it doesn't look like it in Mudbox. So we'll jump back to Marmoset Toolbag 2 and have a look. Yep, we've got rid of a lot of those issues we were having on the edges. We still have some problems though. We've got this little issue here, this one here. We've got these lines aren't straight, and we've got some stretching going on here. Alright, we'll sort that out in a second. First, I'm going to add our newly created ambient occlusion map into our material. So I'm going to scroll down here to the occlusion drop down, hit these arrows, select occlusion maps, and then we want to put click on this square here, select our ambient occlusion, and there we go. I'm just going to go up and turn our gloss down a little bit because we don't need it that high. So what is causing these problems? Well, if you remember when we imported our low poly into Mudbox, we got an issue saying that Mudbox did not like the fact that we had all those edges connected to one poly. Now that is the root for most of these issues. For the life of me, I don't know why exactly that happens, but since we are using Mudbox, we're gonna want to fix those. So back into 3ds Max we go, and what I'm going to do is move this across so we can see a little bit better. I'm going to select these verts here. So they've got selected on both sides. I'm going to hit backspace to get rid of them. Now what I'm going to do is first of all hit F3, so we're going to wireframe mode, and I'm going to select these verts here, so they're selected on both sides, and then I'm going to hit connect to connect those. So I'm going to quad up the front and back of our shield so we don't have that vert in the middle. So I'm going to go through and do that. Select these. I'm going to use the quick button for connection, which is Control Shift E. It's a little bit quicker than doing it than going up and pressing the button all the time. There we go. So now we're all quadded up. So I'm going to put it back into the center again, export it, and then we're going to have to do the bake one more time. So I'm going to jump back into Mudbox, and I'm going to try and do this quickly so you don't have to sit through me doing this again. So delete that, import the new one. There we go. We notice we don't get that error this time. Unhide those, delete those, go to our extraction operation, add all, remove those, scroll down, hit extract, and wait. There we go. Let's jump back into Marmoset 2 and we'll see if those changes that we've made have fixed our problems. Now you can see that that little artifact that we had before has now disappeared, and so has the other one that was on the other side. However, we still have these slits which are a little bit deformed, and we still got some stretching around here. Now those problems aren't actually bake related or height map related. Those are to do with our low poly, and I will show you exactly what I mean. Let's bring up the wireframe. It's a little bit, well, it looks a little bit dodgy over here, but that's only because we have our high poly model in and Marmoset is freaking out a little bit. So once we've got rid of those, you'll see that the other edges are now showing. Now you'll notice that these polys on the edge here are much more dense in terms of edges and verts than these ones here, and that is because they are a lot smaller, and the way that the tessellation works in Marmoset Toolbag 2 is that every poly is tessellated to the same degree. So because these are smaller, more verts and more edges are packed in to that smaller space. So we end up with quite high fidelity here, but a lot less fidelity on the rest of the faces. Now this is easy enough for us to fix. All we have to do is go in and add in some extra edges. Now before I do that, I'm gonna point out something that I haven't actually pointed out yet, and that is if I take down the tessellation, you'll notice that we're using one of the older lower poly versions. We don't have that edge in there, and we haven't quadded this front. And that's because the UVW for both of our low poly meshes, for the newer one and this one, are the same. So we can put the bake or the high poly map, not high poly, height map on this one, and because our UVW coordinates are the same, they will still work. We only created the other version of the low poly, or the newer version, so I say, so that we could get the bake to come out right. But we can still use this, which we will want to do because it is actually lower poly. But since we're going to add in more polys now, it's a little bit redundant, but also having this point in the middle means it's a lot easier for us to add in those extra details, and I'll show you what I mean in a second. We'll pop back to 3ds Max. So with this model we have here, or a newer version, it's a little bit hard to see how we would add in some extra edges without making 5 sides, or without adding extra edges like across here where we wouldn't really need. So we're gonna hit Control Z a few times until it goes back to that model. There we go, it's back in the center. And I'm just going to go in and select these edges here, bring up the connect edges option, and then I'm going to up that till about there, till it's a roughly equal size. Each poly on the front is about equal size to the polys on the edge. I'm going to hit OK, and I'm going to re-export this and replace our low poly model. With that done, we can go back to Marmoset Toolbag 2. I'm going to increase the tessellation on that one, and I'm going to bring in our other mesh so we can compare the two. Let's go ahead and hide the wireframe and put our material on the new one. Now, as you can see, just adding those polys, those extra polys, has made our shield a lot cleaner. We don't have nearly as many of these artifacts on our new one as we did on our old one. So I'm going to go ahead and delete that. And just for the sake of comparison now, I'm going to bring back in the high poly. Let's wait. There we go. And here is our final result. Now this material is a little bit more shiny. It's using the default material, so I'm going to turn that down to about the same level. And we can see that our low poly, which has been displaced, is now almost identical to our high poly. Now you can still see a few little issues with this, but that is because you can see the individual pixels on our height map, and that is easily fixed. If you want to go to that length, you can increase the size of your texture, and that will decrease these artifacts. But I think for our purposes, we don't need to go to those lengths. So that concludes this tutorial on displacement mapping, and I hope you found it useful.